Okay. In this video, we're going to take our hard-coded little example here, and we're going to fill it with actual data coming from the GitHub API instead. So yeah, this little thing here, as you can see, we're going to turn that into actual live data. And I'm going to show you first how to make queries, because that's the thing we're going to be needing here now. But I'm also going to show you how to make queries in two different ways and try and illustrate the differences between them performance-wise. So first off, the first thing we're going to do is we're going to add a query. And in RescriptRelay, there's in the editor tooling, there's a add query. There's a little helper here that's going to help you generate code for this. So you can search for add query, press that, and then you get to select a root field. Doesn't really matter, you're going to be able to edit this as you want, but we know that we are going to be asking for information from the viewer. The viewer is the currently logged in person on GitHub, which is going to be my account then. And then it asks us, do you also want to add a boilerplate for a component, which is quite nice. And I'm going to say yes here, although we already have a component. So I'll just cut out a few things from the generated stuff and add to the one we already have. Yes, and then it asks us, what type of query are you making? Is it a preloaded query or a lazy query? And this is a thing I'm going to show you, the difference between a preloaded and a lazy query, especially for performance. But to start off, we'll start with lazy queries. Lazy queries means that Relay is not going to be... patch this together first. Relay won't start the network request for this until React reaches here and tries to call the query.use function here. At that point, we're going to be starting the network request. This is kind of nice because it means that this is all there is to it. This is self-contained, like this component itself has responsibility for starting fetching its data. It doesn't need any interference from anything outside, from the outside. Nobody else needs to orchestrate like when this data loads and stuff. And that does sound really nice in theory, but it's not that nice in practice, because that means that if this code is inside of something that's code split and then that code needs to load before you can actually initiate the data fetch, and you'll have a waterfall. And we're going to be looking at that waterfall explicitly now as we build out this view. But just to get started, we're going to be asking for information. So if we do this now, we have data here, and we write let's do a small string data viewer ID. You can see that it renders some weird ID out there, which means that we got data from GitHub. Woohoo! This is all it kind of takes. You define your query, and then you somehow execute it and get data back. That's nice, but we all know that from GraphQL since before. Now, what we need here is we need the name, and we need the login. Then we need whenever this was created, the year the user was created, and then the bio. And in this case, the bio is in plain text, I believe. So let's look here for those different informations. We know that there's a name here. Cool. We'll need that one. There's a login. Cool. We'll need that one as well. Created at maybe. Yeah, cool. There's a created at here from which is type datetime. And then there's also hopefully a bio. Yeah, exactly. A bio, that's a string. Cool. Actually, we're going to leave this one out for now, because that's a separate thing I'm going to show you a little bit later on. But starting out, we now have requesting data for name, for login, and for bio. Cool. So let's replace these things with whatever it is we have here. Data, viewer, name. Yeah, and it's going to complain right away because name is an option, and string obviously needs we're going to just do a default for now, and I'm going to show you how you can tackle these things later on. Okay, so it reloads. Cool. well, actually, what we should have done is I'll copy this just for the effect. To show that it's actual data from the server, we're going to do this. Just go ahead and add a bunch of to just signify so that you see in the UI when it actually changes. Cool. You can see that it's all local. Now we'll put this one back. Oh, it's a tie string. There. You can see it renders the name. Perfect. We'll do the same here for the login. And that's a real, like that's all always exists, so that's non-nullable, which is nice. Cool, you can see that one as well, and then we're going to take the bio as well. Bio, and that's also an optional. And actually here, instead of just having a default for the bio, what we can do is there anything else in that div? No, there's not. We can just conditionally render this, because that's quite nice. There we go, bio. Has nothing, we'll render null. If it has a bio, we'll render it inside of our div soup here. There we go. Cool. And it renders it again. Awesome. So I left out the created at here. That's because I want to show you this separately. Created at, it has a type of datetime. And datetime is a custom scalar in the GitHub API. And I'm going to show you some pretty interesting things here. So if we take and we look at data.viewer.createdAt, you'll see that this is the type of RescriptRelay.any. And there's not really anything you can do with RescriptRelay.any, right? And that's because we haven't set up a mapping for that custom scalar. So Relay doesn't know what type we want the custom scalar of datetime to be. So if we go into our Relay config, we have a custom scalar types here. We can add a datetime, and we can say here what we want this to be. I'm a little bit unsure what the underlying thing actually is, but let's, for sake of it, let's say that it's start with seeing if it's a float. And we can see here if we can just do a good old log here. Just log out. Data.viewer.created at. Okay, so it's actually a string. It's the raw date. Cool. That's even better. So we'll say it's a string here. And now as we save this, we'll notice that it's still RescriptRelay.any. And that's because we need to restart the Relay compiler for it to regenerate the types as the correct one. Now it's a string. Cool. Essentially. So we've now told Relay that this is an underlying string. And we know that we can now take this, created at, and date dot from string, and then log this again. We have a proper date. Excellent. We have a proper date. Oh, 2012. Wow, that's longer back than I had envisioned. Cool. Okay, so that's a custom scalar. There's a couple of other cool things that you can do with custom scalars that I'm going to show you as well. We're just going to get this to kind of output information first. So since 2020. So what we want to do is we want to say since and then the year of the date. Get full year, right? And we'll need to string that. Let's see what happens. Since 2012. Since 2012. Awesome. Great. Cool. So one final thing I'm going to show you before we dive into the router and lazy query stuff is that you can actually have this custom scalar automatically converted to a date without having to do that yourself. See here, gonna create a little folder here. Scalars, like you don't have to have a folder called scalars. It's just I like that. I'm gonna create a module, and actually we're gonna be good citizens here and go into the documentation, because what we want to set up now is a auto-converted custom scalar. See here where we have those. We can search instead. Custom scalars. Perfect. Custom scalars. Excellent. Read this documentation page if you're not familiar with custom scalars in RescriptRelay. It really it lays out all the things you can do with custom scalars, and it's pretty cool because it's kind of powerful, actually. And what we're after is this one: automatically decoding and encoding of values. So what we need to do in order for this to work out is we need to set up a module that has a type t here, and then we need to write a parse function to t. Just do that, and then we need to write a serialize function that takes t and returns json.t. Awesome. Oh, sorry. Of course, gotta write valid ReScript. So what's going to happen here is that RescriptRelay will automatically run the parse and serialize functions for you appropriately in order for your interaction with this custom scalar to be able to be just in just as the type you want it to be. And this is really convenient because otherwise you'll always have to convert back and forth manually between the custom scalars. So we have a datetime example here. Perfect. Just go ahead and set this up then. We want t to be a date, right? We want to auto-convert this into a date. So for parse, we'll need to set up a simple parsing of this. We'll know that if it's a string, we can do date from string. And it's always going to be a string, so I'm not going to be, since that's what the API sends back, I'm not going to change anything. Not convert datetime. And again, like normally you would worry about this to have a panic here, but this probably isn't going to hit because we know that the API, whenever datetime is sent back, it's going to be a string. Okay, so we're also going to have to teach it how to serialize. And now we have a date, and we know that we want to return then a string. It's JSON date. Date to ISO string is probably the best one. To JSON, maybe we'll do that. And we'll do a getX in here as well. Yeah, so there we go. Okay, so let me explain here. We haven't wired this up to Relay yet, so let me explain here first how this works. We're defining a custom scalar module. It's just a regular module in ReScript, as you can see here. You could theoretically point it into a submodule as well. I do that sometimes. But yeah, it needs a type T that can be anything. This could be abstract. It could be a link to a type like here, or whatever it is that you want. It can be anything, really. You're responsible for figuring out how to take the JSON information that comes from your API, which is the custom scalar, and turn that into T. And as you can see here, we panic if we don't manage to convert it. So make sure that you are able to convert it. I assume that, like, if you wanted to, you could make this an option and those things. But like, try and stick with actual types here. In our case, we know that it's going to be a string that comes back from the JSON API. So we take that string and we turn it into a date with the date from string function. And if not, we panic. And then as we serialize, we know that we'll get a t, which is going to be a date. And we want to turn that into a JSON thing. So we take the date and we turn it to string, to a JSON string by calling to JSON on the date and then getting the result, because this returns an option. But we know that this is going to work, and if it doesn't work, we're fine with erroring with this error message. So we know where to find the issue we have. Okay, so you'll notice that this is still not a datetime.t. That's what we want to see here now. That's because we haven't wired it up yet. So if we look into the documentation here, you can see that now we have a concrete type, but if we make this a module reference instead, then it's going to try and autoconvert. So there's a difference here. Like first, let's do this datetime.t. Restart the compiler. Then this is going to complain because now it's a datetime.t. But this is actually going to break in runtime because this isn't a datetime.t. We haven't made this auto-converted yet. So let's make this auto-converted by referring to the module itself, like this. Save that, and then go back. Cool. We'll go back to our dashboard. We'll see created at. We'll see that this is now a datetime, a date already. So we'll remove that, go back, and it works. See. So now all of our date times from the API, the datetime custom scalar in GitHub. Oh, come on. That anytime you use that scalar anywhere, whether it's in inputs or in outputs or whatever, it's going to be automatically converted for you to a date. And you have all of the power in here. The RescriptRelay will call this serialize and parse and stuff whenever needed. So that's pretty cool, and that's pretty powerful because it means that custom scalars are kind of like they're a part of your API essentially. So as long as you can parse and serialize, you can kind of transfer any type of structure and information that you want from your API to Relay and still have it be fully typed and without a bunch of manual labor. So that's pretty sweet, I think. Let's go ahead and just inline this thing. Go. What's this? Datetime T. Oh, did it get confused with? Oh, never mind. Never mind. We go. Okay, so that's it for custom scalars. Now I'm going to show you the final thing important in this video, and that is lazy loading. Now notice that we have we now have our setup where we define a query and we make that query using use, which means that it's lazy. I'm going to show you how this looks in the network. We'll build our app to production. Called build here. That creates a dist folder with a client folder. Go in here and we'll call serve on this. Just to set up a basic small server here. Jump into this one. We're rendering our UI. If we go into the network here, hoping that you can see this okay in the video. Let's go into the network. We'll do a fast3g. Disable cache. When we load this, we're going to track what happens here in the network. So, actually, let's make it slow so it's even slower. Cool. So, as we load this, it first contacts the server. Can't do much about that. It loads the base application, which is like Relay and the basic stuff, React. Then it loads the route renderer and the dashboard route. Now, notice this. It loads the route renderer and it loads the dashboard route, and then you can see here in the timeline, and then after that it starts loading the actual data. So this is the first time that it starts calling into the GitHub API. So it needs to load the code for the route in order for this to work. Like this thing is loading the application, the base like kind of framework code. But this is loading the code for the route itself. So this is a waterfall, which means that code here has to load before data can load, which means that this, as you can see here, this takes twice as long as it should be able to. So what we're going to do is we're going to make a very small adjustment here by making this query for the dashboard route preloaded instead of lazy. And that's hopefully going to move loading that code back to here. So that loads in parallel with the, loading the data in parallel with the code itself. Yeah, so shut this down, go back to our developer view and go back here. We can shut down that one. And we're going to turn this into a preloaded query. So in order to use a preloaded, there's a use preloaded function here instead on the query that you defined. But that doesn't take any variables, of course. That takes a query ref. And a query ref is what you get back. Let's take that through the props. A query ref is what you get back when you have when you've started loading a query elsewhere, and that's a preloaded query. Right? Yeah, we can't. It all fails. Of course. Go down here. So now instead, this file complains that can't render this because we need a query ref. And this is inside of the root renderer. Remember that I showed you that the route renderer downloads and then it runs and that renders the component and that starts the network call. So what we will be doing in here instead is we're going to start loading the code or the data, rather, for the dashboard route in here instead. So that splitting up loading code and data is going to be two separate things. And in order for that to work, there's two things that we need to do. We need to make the query in here, and then we also need to code split the dashboard route itself. So let's do both of those. We have our prepare step here. The prepare step gets the environment, and if you had any like path parameters or query parameters, you'd also get these typed here inside of the prepare function. What we want to do is, if we look at dashboard, this is requesting a dashboard query GraphQL query ref. We can point into the dashboard query file. This is generated by the Relay compiler, and there's a load function in here. This load function takes an environment. It takes variables, fetch key, fetch policy, whatever. You don't need to care about any other things here. We'll take variables, and that's going to be nothing because we have no variables for the query. And then finally, we're going to set a fetch policy, store or network. This means that it's fine to render this view with data you already have in the cache if you have it. Otherwise, go to the network, essentially. Save this. Now, remember that we talked about prepare before. We'll now have a prepared prop here. And this is our query ref, because anything you return from prepare is transferred into render via the prepared property. So we can go ahead and pass that into a query ref. And it's all going to load. And it now works. That's great. But that's just half of the story. Since we're in the route renderer here and we're rendering our dashboard route directly, we still have the problem that this route renderer is going to bundle all of the code to render dashboard here as well, which means that we're still going to be delayed before this route renderer loads, and we'll still have a waterfall because we'll need to load all the code anyway. To combat that, there's a built-in thing in RescriptRelay called a deferred component. And it helps you code split route level components like this fast and easy. And what you do is you define a module, dashboard. I'm just mimicking what this is called down here, dashboard, and it's called relay.deferred component. And then we do a we point that to the make function of the thing that we've deferred, essentially. Here we go. Now we have a deferred component instead. So if we look inside of here, we should, this is kind of messy because this is in the local development, but we should be able to see that. See, we don't need slow 3G here. You can see here, which is this one. Right, it starts over there. Okay. But essentially, we now have a deferred component. And what we also need is to start loading this. Let me just check the... That's fine. So working, we need to start loading this data as well. Prepare code. So prepare code is a separate step in the router where you're... There we go. Where the idea is that you can start loading code or assets in different ways. Like here, for instance, we're preparing loading the dashboard code. We're calling preload here, which is an auto-generated function. As you can see, it's all prepared to be able to preload images or styles or whatever. But we're doing a dashboard. We're preloading the code for that here. And the idea here is that we separate preloading or preparing in two different steps. So preparing code and preparing data. And the router then tries to make intelligent decisions around that it's probably safe to eagerly load code rather than eagerly load data. So sometimes it'll start loading the code that you need before it starts loading the data that you need, essentially. So that's that. But just remember this, like you can set up a deferred component and then you preload it, start preloading it here in prepare code, which means that the router is going to be able to optimize it even more, and then you have your data in here. So let's go back to seeing what this, if we build the app, seeing if this did anything for the waterfall. We go, serve in here, cool, localhost 3000. Let's go into network, slow 3G. And reload. See here, loads the thing, loads the framework, loads the route renderer. Cool. Now look, here we go. Here's the code for the dashboard, and that started loading in parallel with the code for the data for that thing. So that's it. Like here we go. We still needed to load our route renderers, but then after loading our route renderers, we can start loading code and data in parallel. And this is really important because this means that it's not creating another waterfall. You can see that we still have kind of a waterfall here in the route renderer itself, and I'm going to show you in later videos how you can reduce this even more. Yeah, but again, like remember, this is important that try and load code and data in parallel as much as possible, because this is making things quite a lot faster, essentially. So to wrap up here, remember deferred component, remember to prepare code, and then remember how easy it is to move a query from being lazy to being prepared or preloaded, essentially. So now the router is responsible for orchestrating when this query starts loading. And that's going to have a bunch of effects later on that I'm going to show you for preloading code and data for other routes, as well as you're navigating and preparing things, which is part of how the router usually makes your app feel quite fast, because it can prepare things intelligently. Okay, I think that's it for this video. I hope you enjoyed it, and see you again soon. Thank you.